Hello everyone. This tutorial provides you an insight on how to create a new cryptocurrency on top of Ethereum blockchain using Solidity programming language. A new currency called T-Coin, or symbolized as TC, must contain all below mentioned features, which I am going to explain one by one. First is, the coin must be called T-Coin and must have symbol as TC. Second is, the creator must be able to specify the initial supply during the creation. So we want to create a cryptocurrency whose initial supply will be decided during the creation or by the creator. This can be called as pre-mined coins. Third, cryptocurrency must be created in such a way that it is transferable from one account to another account, such as ethers. Next is, debt or negative balance should not be allowed. This is simple to understand as we don't want people to have zero or negative balance for transferring T-coins. Though negative balance or debt can be handled, but that is not the scope of this tutorial. The next is there should be one administrator who may or may not be the currency creator. That is, currency creator must make someone as admin during the creation. It means that a person who is creating the currency must assign someone as admin during the time of the creation. Next is anyone must be able to buy or sell T-coins using ethers. You might have some ethers in your account, and if you want to purchase T-coins, which may be less valuable or more valuable than ethers, then they can be exchanged with T-coins. T-coins can represent any physical or virtual assets having value to you. For instance, T-coins can be company shares, or a laptop, or a counter for supply chain management system, or a chair, or a table and things. You can buy or sell things and keep the record for every transaction on the Ethereum blockchain. Next is buy or sell price must be set by the administrator at any time. Admin must be able to transfer the administrator role to any other address. Let's suppose if admin wants to leave, then the role must be transferable to others. Next is, admin can also mint the T-coins to anyone's address. For example, I purchased 5 gold bars. I want my inventory or my record or my ledger to be updated and matched with the purchase I made. To show that, I need to add new coins which represent 1 gold bar. This is the reason you mint new coins in any cryptocurrency, because you want the physical assets and the virtual assets to be matched, so that they can be represented in the real world. Moving on to next feature, the admin must be able to freeze or unfreeze the coins of anyone's account, because there might be a case where you want to freeze the assets or whatever the value you used to represent using coins. Next is proof of work, must be there for the consensus. We will implement a proof of work consensus algorithm where we will ensure that anybody adding the new block to the blockchain is actually performing some mathematical computation. Next is miners must be challenged and rewarded a new T-coin for every block he/she mines, for every minute since last block. We will also set up the system to adjust difficulty automatically to achieve 10 minutes average block time. All this will be implemented using the programming language. Before proceeding, we will create a minimal viable cryptocurrency, which may be called as Stage 1 cryptocurrency, and then we will execute it. We will be creating a zero-level cryptocurrency, which will be called the smallest cryptocurrency, and learn how to deploy it. So, we'll begin with the Solidity compiler version, which is defined as Pragma Solidity, and the compiler version 0.4.22. Using the code Pragma Solidity $0.4.22 . This line defines Solidity compiler version on which this smart contract gets compiled. The sign means that this program is compatible with the minimum compiler version of 0.4.22 and above, such as 0.4.23, 0.4.24, and so on, but below 0.5.0. After this, we will make a contract with the name of our coin, T-coin. Contracts in Solidity act similar to the classes in an object-oriented programming language. Inside this contract, we'll define a mapping which will map an address to an unsigned integer of 256 bits, and will make it accessible from anywhere using public access specifier. Here, we are storing the balance of an address. Address stores the account address and is mapped to the unsigned integer of 256 bits. We are naming the mapping as balance of. As mentioned earlier, contract acts similar to a class and object-oriented programming language, so we need to create a constructor of this particular contract. To create a constructor, use the keyword constructor, and as the parameter of this constructor, we'll define a variable initial supply of unsigned integer 256 bits. This variable will store the initial supply of the cryptocurrency. We'll make constructor public. We have to transfer all the initial supply of the coin to the creator of this contract, which we can call the admin. To do this, we are accessing the balance of admin using the code balance of square bracket message.sender end square bracket equals initial supply semicolon. Here, balance of admin is initialized with the variable initial supply. The code message.sender takes the address of the creator of this contract, which you can say is admin. Till this point, we have created a cryptocurrency and provided its initial supply here. Next, we are going to create a transfer function to transfer the coin from one account to another account. To do this, we'll create a public function with the name transfer having two arguments. First with the name _2 of address type, which indicates the receiver's address to which transfer of Tcoin is made. Second argument with the name value of unsigned integer of 256 bits, which indicates the value of the coins to be transferred. This function performs two tasks: deduction in the sender's balance and other, addition in the receiver's balance. To perform the deduction, use the code balance of square bracket message.sender end square brackets minus equal sign underscore value semicolon. And to perform the increment in the receiver's balance, use the code balance of square bracket underscore 2 end square brackets plus equals underscore value semicolon. In this lecture, we wrote a Solidity smart contract where a cryptocurrency Tcoin is created with the function of transferring the amount from one account to another. In the next tutorial, we will execute this smart contract on the Solidity compiler to check its smooth working. Thank you. Hope you understood till this point.